Welcome to Smart Software, a podcast where we talk about best practices in web and mobile software development with a focus on new and emerging technologies. My name is Justin Seepin, and I'll be your host today. I'm a developer at SmartLogic, a Baltimore-based consulting company that has been building custom web and mobile software applications since 2005. From my team today, I'm joined by the wizard, Eric Ostrich, and we are working on the second season of Smart Software. So we're talking about Elixir internals. We'll be talking today about the inner workings of some popular Elixir libraries written by none other than Chris Keathley. How are you, Chris?
I'm good. How are y'all?
Really, really well. Really glad to have you, Chris. You're working at Bleacher Report right now. We would love it if you could just take a few minutes, introduce yourself, tell us about your background, how you got started with Elixir, the company that you're currently working at.
Yeah, so I don't know. I've been doing Elixir for a while now. I've lost track, which tells me it's long enough. And yeah, I've been working at Bleacher Report for a little over a year and some change, mostly building out a bunch of different services there and working on like Kafka consuming and data pipeline stuff and optimizing things and tuning services and all these kinds of things, all these fun things that you get to do when you're at scale for whatever.
About how much of Bleacher Report is on Elixir?
Just about all of it. There's a few legacy things like, I kind of hate the term like legacy. There's a few old pieces of software that we still maintain that are in Ruby. There's some new things that are written in Ruby for like reasons, mostly due to like gaps in Erlang and Elixir as an ecosystem. But for the most part, I think almost everything is written in Elixir, especially on the back end. There is some like C# floating around, but that's like a totally different, it's like 3 dedicated people and all they work on is like C#. One of them is learning some Elixir in his like spare time so he can work on these other services when he needs to. But yeah, for the most part, everything is, like I said, everything's in Elixir. There's only a real small, like we're a relatively small team from a back-end engineering perspective. The majority of our engineers, Bleacher Report, are actually on the client side of things. So either web, iOS, Android, what have you. And I think there's only about, I don't know, somewhere in the vicinity of like 12 back-end people total, managing way more than that in services. And so, yeah, it's a lot of fun. You get to like be involved in a lot of different things and get to wear a bunch of different hats.
All right. So you've got a lot of open source work under your belt. How did you begin with all that?
So I kind of started doing like contributing, I guess, a lot of like open source stuff, more or less in conjunction with when I was like doing Elixir, learning Elixir. I guess it's not exactly true. I was probably hanging out in the Elixir world for a little while before I like really contributed anything of note. But the first project that I ever built, like the first like main open source thing that I like worked on and maintained was this, acceptance testing tool. Like it drives web browsers called Wallaby. And that was written in Elixir. And I basically wrote that because like whenever I would come up against new projects at the company I was working at the time, we'd always pitch Elixir. There's like 2 of us who were like really into it at the time. And we'd always like pitch that as our like go-to solution. But there's just a ton of pushback because like stuff was missing from the ecosystem and like no one really knew how to do anything. And like you'd go to look for something that closely approximated a tool that you had in your tool belt and you can't find it. And so where I was working is predominantly like a Rails shop. They like, and even when they're not doing Rails, they like to think about and talk about Rails. Like it's like that's kind of like where their heart is. And so one of the tools that they kept asking for was this acceptance testing tool in Ruby called Capybara. Like, where's this equivalent in Elixir? And there wasn't one. I mean, there was a thing called Hound, but no one liked it. And like, no one liked the API. I mean, not to like disparage that library. Like, it's probably a great library. I've never used it, but like, they wasn't to their tastes, let's say. So they kept kind of asking for that kind of stuff. And at the time, the latest like RC for Ecto had come out and it could support database sandboxing. And so because like they didn't love Hound's API and Hound didn't support that feature at the time, we were sort of like, let's build it ourselves. Let's just like go for it. And so, yeah, me and that other guy, like, I don't know, hacked it together. I was in San Francisco for a trip and like we basically came up with it, hacked it together, and then just kind of kept on contributing to it over time. And then everything's sort of fallen into place after that.
I feel like you're being modest here because, I mean, we use Wallaby at Smart Logic. It's what we use for integration testing. Why, are you still working on Wallaby? I know that you were looking for a new contributor at some point. What's happening?
Well, so, I mean, the big thing is like, I just don't work on front ends anymore, basically at all. I realized this the other day, like I haven't written HTML or CSS or any of those things in over a year. Like I just don't do that work anymore. Someone else is doing that work, and that's great because I've never been great at that work to begin with. So because of that, like I just had less call to work on it, and there was less like motivating me to work on it. And plus, like you work with browsers for that long and like try to keep all that stuff working correctly and optimized, and like it just becomes a chore. So
it is still like the default.
Well, I mean, I'm glad that people really like it. I'm glad that people use it. And, I think getting that API right took a long time. And so we do a lot of things to really try to make that API really pleasant. And it's worked to like greater and lesser effect. That took a long time to kind of discover that API and figure out what was right. But yeah, so like at the end of the day, like there's just other stuff I want to be working on and that I think warrants my time. And I think Wallaby's at a place where it's in, like it can be maintained. And right now there's a couple people who've really stepped up to like provide that maintainership, and they're actively working on removing a lot of the old stuff that doesn't need to be in there anymore, like dropping Phantom out of there. Like we're not going to support that anymore. Like they're working on like shoring up all these things. So that's great. It's in good hands. I'm not worried about it. I need to like update my blog because people still cite it as like a reason not to use the library. Like they point to my blog post I wrote about it and they're like, oh, well, it's not maintained anymore. And I need to update it and add a little addendum at the top that says solved, closing the bug. But yeah.
So Wallaby is still a thing.
Mm-hmm.
We use Wallaby. Still using Wallaby.
I need to do what the Clojure community does and put proof of life like notes in their readmes, because their stuff tends to be super stable and not change that often, that they'll literally update the readmes with like, yep, it still is good. You can still use it.
That's great. I'll have to look into that. So we're going to talk about some of your other libraries, but I do want to give you a chance, like, especially because it sounds like it was your first major open source endeavor. Like, is there anything that you had to overcome while building Wallaby, or anything that you learned from it that like really sticks with you that other people should know about or think about?
Oh man, I'm trying to think. Yeah, don't build things with browsers. That sucks. That's takeaway one.
Browsers.
Yeah, they're really bad. No, I mean, in some ways I got really lucky because it was sort of like right place at the right time. And I happened to fill a need, and that project opened a ton of doors for me. Like in the sense that all of a sudden, like people flew me to meetups and like wanted to hear about it. And like I gave a talk on it at ElixirConf. That was my first ElixirConf talk, was about Wallaby. So it's like that project holds like a special place in my heart because of what it meant to me. It was like this tangible connection to the Elixir ecosystem. So that was really fun. But a lot of the work that went into it, I mean, it's a lot of work. Any project that gets any amount of support or traction, it ends up being a ton of work. And so you have to go into it very clear-eyed with like, are you going to maintain this? And I think it's actually fine to go into it and say, I don't want to. I'm going to build this thing and put it out there, but I'm going to make no effort to maintain it. And I actually think that's like totally valid. Just as long as like you're upfront about that with people. And so these days, like on all of my readmes for all my projects, for the most part, I put some sort of like caveat at the bottom that more or less says like, should you use this in production? Like almost all of them have like some point at the bottom that says like, should you use it in production? I think almost all of them say no, like for that reason, just because like, some of the, well, partially because a lot of the stuff I work on is like distributed system stuff, and I'm not comfortable with other people just using it. And part of it's because it's sort of like, I don't necessarily want to be on the hook for maintaining it. It's more there to like inspire people. There's like select things that I really care about maintaining.
Yeah, I have at least one project as well it's a simple leadership election or whatever, and it's like, should I use this? Like, no, this works for my production, but it may not work for yours. Like,
right.
So yeah, so one specific question I did have about Wallaby is, how does the Ecto Sandbox work with concurrent tests? Because I know that's a thing you can do, but I don't think I've ever understood how that could work. How
that actually works? There's a bunch of caveats. That's how it works. Right? As of my memory, this might have changed, but last I checked, the only database that actually supports the Sandbox correctly is Postgres. So if you're using any other database, it does not work. Like you just can't do it. But the way it works under the hood is that if you're inside of a Sandbox connection, effectively what's happening is every transaction is being opened inside the previous one. And so you get this layer of like nested transactions. And so when it rolls back all of them. So you can safely share your connection and no one else is going to see, anybody else who's using that same Sandbox connection can see your stuff, but no one else outside that Sandbox can. So you can have multiple Sandbox connections all running at the same time and you don't pollute the internal database. That's how it works in theory. And that part does work. It's just that last I checked, it only works with Postgres because like MySQL can't do the nested transactions necessary to be able to do that. And then and that's like setting aside the databases that just don't have like some sort of transactional support, like true transactional support in that way, right? So like if you don't have like true concurrency control around your data, then you may not be able to support that. So yeah, so you got to use Postgres 1. And then what happens is that when you check out the Sandbox connection, there's a specific plug that we take advantage of. And actually we wrote like forever ago, like me and the guy who helped me, Tommy, the guy who helped me write Wallaby. We actually built this like plug that sits there. And originally, and this probably changed too, but originally it ripped the Ecto Sandbox connection, which we just ETF, or we convert into Erlang term format using Erlang term to binary and binary to term. And we stuff it in the user agent string for the browser. And so that's how like you get the Sandbox connection into the Elixir app, like from some browser somewhere. So it actually comes in through the user agent string. And I think it was in a cookie originally, but like cookies aren't always like sanitized in these headless browsers. And then like, I think we ended up putting it in the user agent string because like that's long enough that allows like enough space to like hold all the data we need or something. I don't remember. There's like a whole bunch of stuff that I've long since forgotten that had to happen to make that work. But yeah, that plug rips out that it lifts out the connection information, and then it uses that internally to make sure all that your database transactions are like sanitized internally.
That's amazing. And I think that was the plug piece was the part that I couldn't figure out how it would work.
Yeah. That took a minute. I remember being like, I think at the time, like, I think this was even like pre-Slack. Like there wasn't an Elixir Slack at the time. Like it was just like IRC and 20 of us or whatever. Like, it's like no one. And so, yeah, I remember we were talking to Jose on IRC about it. Like, how do we even do this? Like, because at the time, like they had built the Sandbox thing, like James Fish had built the Sandbox thing, but no one knew how to utilize it. Like we had no idea like how to take advantage of it. So yeah, it took a minute. We had to stop and figure out some janky hacks to like actually use it, but it ended up working out.
So on your GitHub page, you've got at the top 6 different Elixir libraries. You're clearly like prolific in the open source world. And we knew we wanted to talk about Wallaby because we use it, but you've got Norm, Schism, Raft, Vapor, Alchemy. What are you working on like right now? And what do you think is the most interesting to talk about from like if we were going to do a deep dive technical perspective type of thing?
Well, so like, what's the most interesting? I mean, Raft is probably the most interesting, but I'm not actively working on it. Although it keeps like, twitching at the back of my brain. Like that's like a thing that I keep wanting to go back to.
I
just think it's a fun project. Like it's a fun project. There's a lot going on with it. It's a technically really challenging project. Like getting Raft right is really hard. Like getting all of Raft right is really hard. And that's the thing. Like you can't like half implement anything. Like you have to get all of those invariants correct or none of it works.
So I know what Raft is because Eric has given multiple talks on it. But for people who are listening who don't know what Raft is, what is Raft?
So Raft is a consensus algorithm. And what that means is you can have multiple computers arrive over a network, arrive at a decision about some piece of state, something. And they can all arrive and say, like, this is what it should be. We've all agreed that this is what it ought to be. And that actually is like an famously hard problem. And for the same reasons that like 2 computers can't reliably tell each other what time it is. That's just like physics don't allow you to do that. So you have to come up with these algorithms to like support the ability to arrive at consistent state somewhere. And so Raft is way to do that. It's based on multi-Paxos. It's essentially multi-Paxos.
I've never heard this term.
Multi-Paxos. Anyway, Paxos is an algorithm. Paxos is also famous algorithm, like infamously hard to understand algorithm. This guy, Leslie Lamport, who's a certifiable genius, but also a little bit like interesting, like has a very interesting like teaching style. He came up with this algorithm called Paxos, which achieves the ability to do like consensus across multiple computers. And the thing with the original Paxos thing though, is that his original algorithm was that it only supported like consensus once, basically. Like you got to do it exactly one time on like one register, like one thing, like, that was it. And so, but the idea is that you just do it multiple times. And that is what people called multi-decree Paxos or multi-Paxos. Anyway, Raft like follows in that lineage. And because consensus is generally like really hard problem, Raft optimizes for understandability. Although the original paper I still think is grossly underspecified in certain parts, but that's neither here nor there. So in any case, yeah, Raft is like this more easily understandable algorithm in order to achieve consensus. And it makes trade-offs. It actually makes like huge performance trade-offs in order to be understandable.
I'll just note that Paxos under computer science on Wikipedia is a fascinating Wikipedia page.
Yeah, the whole history of consensus is really, really interesting. And it's funny because forever like Paxos is sort of this thing that people refer to as like the consensus algorithm, except that it's like so underspecified. Like it's sort of specified in this like very vague, almost like allegorical way that everybody who implements it does it slightly differently. And they all implement like their own versions of it. And like there's papers that are written by companies who build Paxos systems that are literally like, here's how we built it because no one else knew how. Like there's a paper called Paxos Made Live that Google wrote forever ago. It's an amazing paper. It's really, really fun read. And it describes how they built a Paxos consensus system. And yeah, they're basically like, well, you have to kind of read the papers and then guess and then like fill in all the rest of it. So yeah, there's a whole bunch of those sort of algorithms out there. Yeah,
I will say that if you go to raft.github.io, they have a nice little visualization that kind of shows how it works, and you can kind of play around with it and stop nodes and start nodes and whatnot. So that's something to check out.
Yeah, Raft overall is pretty easy to understand. The original paper is very easy to read, but they more or less like hand wave over a lot of stuff that you have to do from an operational concern. Like they basically hand wave over how cluster configuration works. And it turns out when you're building a system, you don't just instantly have a cluster. Like that's the first thing you need to build is like, I need to get a cluster of nodes, but you can't just turn on all the nodes, have them connect and be like, these are my nodes. That doesn't work because you'll end up with incorrect states. Like you can't trust like the nodes that you can see being the nodes in your cluster. So you have to have this like regimented way of talking about node cluster configuration changes with like additionally adding new nodes or removing nodes or whatever the case may be. And you have to do that operationally, and those have to be RPCs, and it's a whole thing. So the thesis, which I read much after, actually does explain all that stuff, and it's like fully complete. And he does away with some of the dangerous stuff that's specified in the like very short, like 10-page paper.
I don't think I knew there was a follow-up to that, so that's cool.
Yeah, the thesis, his thesis about that Raft system is very complete and good. And he does away with the original Raft paper specifies this sort of intermediary phase when you're adding and removing nodes when you're doing a configuration change called like joint consensus. And it's dangerous. Like it's dangerous in practice to actually do that. Like you don't ever want to do that. And so, because it's like it passes, your TLA plus proof, but that doesn't mean that it's like a safe thing to actually do in practice, like from an operational perspective. So yeah, the thesis though explains a better way to do it.
So do you want to talk at all about the work that you've done on Raft as a developer and maybe give us a little bit of insight as to like how the library works and how you've contributed to it?
Yeah, sure. So the library itself, it's not overly complicated. The trick is like getting all of the state machine transitions correct. Like, so What I mean by that is internally, when you're building a Raft system, you have an internal state machine that, how do I explain this? This is going to be like impossible to explain like with voice, like how Raft works as like an algorithm. But basically the way it works is you have multiple processes. For just like making it succinct, we'll say that these are nodes, but they could just be a gen server. Like it could be any process on any node. So you have some process somewhere, and you have some cluster of them. You have some known set of them that are all going to try to agree on some value. And each of those processes is a state machine. And it can either be in a leader state, a follower state, or a candidate state. And a candidate state is when you're trying to become a leader. And what ends up happening is that the Raft algorithm elects a leader, and it does this through a bunch of different invariants. It uses several invariants to elect leaders. So like you have to have an up-to-date log. You have to have, there's a bunch of, I'm trying to remember all the exact invariants, but there's all these like rules. There's these rules around like who can be a leader of the system. And once you get elected, Raft maintains a single leader for as long as it possibly can. And that leader serializes all reads and writes through it. So if it gets a new write, it first commits it to its durable log. It says, hey, all of my other followers, replicate these things, please. It'll send them RPCs. They'll be told to replicate. And at some point, they respond back and say, yep, we did it. And then once you're done with that whole round of stuff and replication, once you've replicated to a majority of nodes, you can sort of say, like, this is committed now. This is now a thing that's happened in the world. And you can return that back to the client. And so you give that back, and they can then like move forward with their lives. So, and you do this over and over and over and over and over again. And this is how Raft maintains consistency, or one of the ways Raft maintains consistency. Internally, you use a log. It has to be durable. You have to store it, or else you can't do cluster configuration. You can't elect leaders. You can't do any of those things. Like none of that stuff is safe if you don't have like a durable log that you store to. And at that point, this is where like most people in Elixir are like, oh, I'm out because I'm running on Kubernetes and I don't have file systems anymore, which is like, okay, well, that's cool. Like that's fine. But you know, it doesn't work without any of that stuff. So you have to write it some sort of log, and it needs to be durable because you have to be able to recover from crashes that could happen like in between you replicating and you writing stuff and whatever else. But if you do this over and over again, what you get is this sort of semi-immutable log of things. It's not actually immutable, but like from the leader's perspective, it's immutable. And you get this sort of ever increasing log of stuff that's happened. And from that, you can rebuild the world. And so, and you can technically model basically, you know, and it's sort of like the event sourcing thing. Like you can kind of model all these different problems as like a set of events that have happened. Raft is similar to that, right? It's a log of stuff that's happened in the past, and you can, you know, fold over it and then build a new version of the world. So that's like the very, very high level view of like the algorithm. Internally, we use a combination of things to make that happen. So each Raft instance is actually two different distinct processes. One is the actual state machine process. That's a gen statum process, which makes it really convenient to build state machines and handle timeouts and all these kinds of things. Statum is like the scala of OTP behaviors. It's like every good idea anybody's ever had was shoved into this one behavior. It's just got everything in there, including some stuff that's like kind of annoying. But gen statum is really cool. Each server consists of a gen statum process and then a log process. And the log process is there because since we know that there's a single log, we can do some like smart caching of things in that log process. But the log process sits there and it writes stuff when it needs to into RocksDB. And we use RocksDB under the hood for actually holding all this data. And RocksDB has a bunch of interesting, good properties, not the least of which is just that it's really easy to embed into Elixir systems and it's really fast. So we use RocksDB under the hood to store things. And yeah, those two processes work together to maintain state, to write things to disk, all that kind of stuff.
Boy, I think we could definitely do a full episode just on consensus algorithms. We could probably do 10.
Yeah, I mean, it's a lot. There's a lot of stuff in there. And Raft, I mean, the thing is like Raft's like main goal was to be understandable, which is like kind of a hilarious goal if you really think about it, because it's like an unknowable thing. It's like an unmeasurable thing. But for the most part, it worked because that was the algorithm that basically everybody implemented. It's like what's built into etcd. I'm trying to remember some of the other stuff, but it's used in console. Like it's used in all these things because it is easy to understand, but it's actually really slow. Like as far as consensus algorithms go, it is not speedy. And it makes that trade-off basically just because it's trying to be easier to build in a way that's like verifiable. Well,
Chris, it's been a pleasure to have you on the show. We are at time, and I want to make sure that you have time to shamelessly self-promote. I know Eric and I would be delighted to have you on the show again. So please, let's make that happen. Do you have any final plugs, shameless self-promotion, social media? Where can people find you, your libraries, that kind of thing? How to get involved with your projects?
Yeah, all my stuff's on GitHub. I'm Keathley on GitHub. And you're welcome to like check that stuff out, submit issues or comments or whatever. I don't have social media. Like I quit it all. So I don't have anything to promote there. But, the last thing I'll say is like we're doing training at ElixirConf. I'll be doing trainings at Codebeam Lights kind of around coming up. So if you're interested in learning about like distributed systems and this kind of stuff, like definitely feel free to check that out. And I also run a podcast with some friends called Elixir Outlaws. So if you're interested in other podcasts, like feel free to come by and check that out as well. We typically just like shuck and jive for an hour, and sometimes it's about Elixir.
Well, that's been Chris Keathley, everybody. What a terrific episode. Once again, this has been an episode of Smart Software with Smart Logic talking about Elixir internals. Join us again next time for more deep dives into Elixir itself and Elixir libraries. Chris Keathley, Eric Ostrich. My name is Justice Eben. Thank you for tuning in.